Lesson 3, Part 2. This is number 5. Solve by the addition method. You may want to first clear each equation of fractions. I don't know about you, but I don't see any fractions. Okay, remember our goal. When we're doing the addition method, we want one variable with the same but opposite coefficients. So my x's don't have the same or opposite. My y's don't have the same or opposite. I do notice, though, that if you take 3 and multiply by 2, you get 6. And I notice if you take 5 and multiply by 2, you get 10. So I'm going to work with my second equation, and I don't want to multiply by just 2, because 2 times this gives you positive 6, and 2 times this gives you negative 10. I need opposite in sign, so it needs to be multiplied through by negative 2. Looks like I'm going to be picking on the x's. I want to get rid of the x's, so I'm multiplying both sides by negative 2. When I multiply through by negative 2, that becomes negative 6x. Negative 2 times negative 5y becomes positive 10y. And don't forget over here, that becomes negative 10. So now I'm going to ignore this equation here. I'm going to take 6x, subtract 6x, and I get 0. I'm going to take this negative 10y and add 10y, and I get 0. Over here I have 15. I'm going to add negative 10, and I get positive 5. This gives me 0 equals 5, and that is false. And like I said on the last problem, students will get to this point and then fizzle, because they don't know what this means. If you get a false statement, it doesn't mean you did anything wrong. It means there's no value for x or y that's ever going to be a solution of the system, because they're parallel lines. So there's no solution. If you get confused, you can put both of those equations into slope-intercept form and take a look at the equations. That's a good way to double check to, if you get one of these weird answers, put them in slope-intercept form and take a look at them. You can tell. And it looks like it's going through it again. All right, here's all of the steps for the addition method. I'm not going to read through all of that. You're welcome to pause the video and take a look. I'm going to move on. Okay, now that we know how to solve systems of equations using 3 methods, we've got the graphing method, we've got substitution method, and we've got the addition method. Now we're going to have to look at a few word problems. Some of these are on the lecture guide and some are not, because I wanted to make sure I not only covered word problems you're going to see in lesson 3, but some word problems you're also going to see on the reviews and on the test. So let's get this started. All right, this one is not on the lecture guide, but it's in my math lab. This one says a restaurant has 20 tables. Each table can seat either 4 people or 6 people. The restaurant can seat a total of 90 people. Find the number of each type of table. Okay. With these word problems, I am a table girl. And my tables always have 3 rows and 4 columns. And I like to organize all my data in a table. The top row and the first column are just going to be title, rows, and columns. All right, so I am dealing with 4-person tables and 6-person tables. And they give me some totals. I want to know, they tell me the number of tables that we have. We have 20. And they tell me the total number of people that will fit in the restaurant, or total number of seats. Number of seats represents number of people. I need to define my variables. What is it that we don't know? Well, look in the last equation. It says find the number of each type of table. So I've decided, you can use X and Y, but I decided to let a 4-person table be represented by F and a 6-person table to be represented by S. So this is the number of 4-person tables and the number of 6-person tables. When I add those two numbers together, it should add up to what? Yeah, 20 tables. The number of 4-person tables plus the number of 6-person tables has to add up to 20 tables. The second equation is based on the number of seats available. Well, you know, a 4-person table has 4 seats. So 4 seats per table times the number of tables gives me the number of seats available at 4-person tables. Here, there's 6 seats at a 6-person table, so 6 seats times the number of tables, number of that type of tables, gives us the total number of seats for 6-person tables. And if I add those together, it should add up to a total of how many seats? Yeah, 90 seats. There's your two equations. F plus S equals 20. This is based on the number of tables. The second equation is based on the number of seats available. Now, I would solve this with the addition method. But since we just got done talking about, I would use substitution. I'm a substitution kind of girl. Some people love the addition method, so I decided I will do it both ways. If we're going to use the substitution method, I'm going to either solve for F or S in this first equation. So I decided to subtract S from both sides here. F equals 20 subtract S. And I'm going to substitute this expression in for F in the second equation. So 20 minus S goes in for F. I'm going to distribute my 4. So that's 80 minus 4S plus 6S equals 90. Combine like terms right here. 80 plus 2S is 90. I'm going to subtract 80 from both sides and divide both sides by 2. I have 5, let's see, S stands for 6-person tables. I have 5 6-person tables. So if I have 5 6-person tables, right here, 5, some number plus 5 is 20, F has to be 15. I have 15 4-person tables and 5 6-person tables. If I do the addition method, what I did here was I decided to eliminate my F terms. So I multiplied everything in the first equation by -4. -4F minus 4S equals -80. I'm going to bring down that second equation and I'm going to add them together. My F terms cancel each other out. -4S plus 6S is 2S. And -80 plus 90 is 10. Divide both sides by 2 and you get S equals 5. Plug that back into the first equation. F has to be 15. So the number of 4-person tables is 15 and the number of 6-person tables is 5. It didn't say which method to use, so you get to pick a method.